Hello everyone, this is Shivam and today we are going to start a very important manufacturing process, that is casting process. Before starting casting process, we are just going to see a very brief introduction about manufacturing process. So what is manufacturing process? In simple words, if we can define manufacturing process, it is just a process of converting the raw materials into finished object. And when we are saying that we are just converting raw material into finished object, that means we are simply adding value to the raw material, and after that the finished project product which we will get, that is having some market value or some economic value. That's why what it is written यहाँ पे हम लोग देख लेते हैं. It is a process of converting raw material into finished object, and we are just adding value addition process into raw material such that the final object is having some market value or some economic value. After that we will see the classification of manufacturing process. So what is the classification of manufacturing process? So manufacturing process are basically classified into four categories. That is, first one is casting process, second one comes forming process, third one is known as fabrication process, or we also call it welding process, and fourth one is material removal process. So when you will go in detail about casting and forming process, you will come to know that in casting and forming, no metal, either metal is added or removed in casting or forming process. We are just converting one form of metal into another, or we are just deforming metal in different shapes as per our requirement. So casting and forming process both are also known as zero process. And third one is fabrication process, welding process. We know in welding, to just weld two different metals we need filler materials in addition, so extra metal is just added in this process. That's why it is also known as additive process. And fourth one is known as material removal process or machining process. There are different types of machining process like turning, grinding, milling, facing, taper turning. So in all these material removal process, we are just removing the extra material from the that casted object or different types of formed object to get the predefined shape. So one more type of classification of manufacturing process is also known as zero process, second one is additive process, and third one is subtractive process. In interviews mostly they directly ask what is zero process or additive process or subtractive process. You need to take just keep all these things in mind. Here you can see there is just a flow chart in which it is shown that when we are just extracting the ore from the earth's core or earth's inner surface, then how it is just processed in different kinds, so that we at final stage we just get casting or casted object. So what happens, we just get Fe3O4 or Fe2O3, and this is the kind, or this is the type of ores which we get, which is having ample amount of impurities. So after this ore which is having large amount of impurities, we just put it in furnace, and it is heated to certain amount of temperature, and due to that impurities are just extracted from it, and we just get pure form of metal. It may be in the form of billet or bloom or different shapes, and this liquid metal is further mixed with different kinds of alloys like tungsten or molybdenum, or different percentage of carbon, so that we can get the different kind of steel, and this steel is further used to just get or cast, is just casted after it is melted. After that we are just going to start casting, which is our main topic, which today we are going to start. So what is casting? Casting is a process in which the molten metal or liquid metal is allowed to solidify in a predefined mold cavity. When we are saying predefined mold cavity, that means we have already made the cavity, and we are just pouring the molten metal into it, and we are just getting the final object. What happens actually, you can say that and after the solidification we just break this casting, and we cut out the gating elements from it, and we will get the final object. Here you can see this is a complete molding box, and when I am saying molding box, it consists of two parts. First one, the lower part is known as drag, and the upper part is known as scope. Other elements of the gating elements of this molding casting is known, it is written. First one is pouring basin. So the molten metal is poured in this pouring basin, and through this gating element or through this sprue the molten metal just flows into, and then comes runner, and after runner there is ingate, and from ingate the molten metal enters into this mold cavity. Whatever the kind of shape or size of the final casting which we need, we just make that shape in the form of mold cavity, and molten metal just solidifies here. You can see one thing more, here is riser. So what is the use of riser? What happens when molten metal is poured into it and when it is filled up to top, when it is solidifying, there are certain contractions in molten metal. So to solidify the or to compensate this contraction, we just use riser. So when there is contraction, the liquid metal from the riser just compensate that contraction, and so that we don't get any defect in the final casting. After solidification, you can see that after final solidification we just get this kind of solidified object. Along with it there will be gating elements. With the help of draw spikes we just take out this casting, and then getting elements are cut and we will get the final casting. इसके बाद आता है, there are three components of casting. First one is the pattern which we use to make the mold cavity. Second one is molding sand. All these which you are seeing is molding sand which is rammed in this molding box. And third one is the tools which we use. So next topic is molding box. This is what I have told you, that this is a molding box. So there are basically two kinds of molding box, two box system, and second one is three box system. So when two boxes will be used and when three box system will be used, that we will see. If the casting is of simple shape and size, then we just prefer two box system. And in two box system you can see in figure there is scope and second one is drag. And if there is some complex or intricate shape, there we just prefer three box system, and in three box system there is scope, second is cheek, and third one is drag. As you can see here it is written. Now here it is written what is draw spike. Already I have shown you this is draw spike and what is, for what purpose it is used. We just use draw spike to remove the final solidified casting by shaking the mold cavity from casted product. Now before moving further, I just want to show you one of the videos which will make more clear what actually casting is and how sand casting is done, and I will be explaining it. Here you can see that this is a drag box, and in drag box we are just putting this pattern, the kind of object which we want actually to be solidified or casted. That kind of pattern we will make first of all, and then we will put, this is drag box, in that drag box we will put that pattern which you can see, and after that sand or molding sand will be put and we will ram it properly, and it will be filled up to top. It is just inverted molding drag box, so we will just make it upside down, and you will see this just making it upside down. And then we will put the cope box on this, and dowel pins will be used to just fix it so that it doesn't mismatch. And after that the other half part of the pattern will be put and molding sand will be rammed on it. You will just see here dowel pins have been put, and then casting this ramming will be done. And after this ramming we will just make the pouring basin or the gating elements which you have seen. These gating elements will be designed, and after the gating elements are designed, this pattern will be removed from this and we will get the mold cavity. And after this we will design the gating elements and riser is designed, and after that molten metal will be allowed to solidify in it. So you can see this is the cavity, and these are the gating elements which are just designed like this. And then you will see that molten metal you can see is filling from it, and this will be filled in the riser. And when there will be solidification, you just see the height of the molten metal is just lowered because it has just compensated the contraction. After solidification, we will just remove this drag and cope box and we will get the final casting. So you have understood what actually casting process is. Further we will move to the advantage of casting. तो casting का क्या advantage होता है वो हम देखते हैं. कास्टिंग का सबसे बड़ा एडवांटेज ये होता है कि आप किसी भी कॉम्प्लेक्स शेप या साइज का ऑब्जेक्ट आप कास्ट कर सकते हैं. व्हाट यू नीड टू डू इज जस्ट टू मेक द पैटर्न, द एग्जैक्ट शेप ऑफ पैटर्न विच यू वांट अकॉर्डिंग. जिस तरह का आपको फाइनल ऑब्जेक्ट चाहिए उस तरह का आपको बस पैटर्न बनाना है, एंड आफ्टर दैट यू विल गेट दैट काइंड ऑफ casting. Second one is it is less expensive. Why it is less expensive? Because this scope or drag box can be used multiple times. Second one is used pattern. So pattern you can use either of metal or of wood, so that is not also costly. And third major one is used is molding sand. So molding sand can also be used multiple times. So what you can see is it is relatively less expensive from other casting processes like forming, casting or welding, sorry, this kind of processes. Third is ductile and brittle materials can also be casted or produced in other manufacturing processes like in uh, forming or welding. You will see that in forming and welding we mostly prefer ductile materials because brittle materials can't be deformed. But this is not the problem with casting. We can cast any kind of materials. What we have to do just is to just melt it or bring it to the melting point temperature, and we have to pour the molten metal into this cavity or this gating element, and we will get the casting. Fourth important advantage of casting is that we can cast large size of objects, and its size can be up to 100 to 150 tons. Some of the examples of casted objects are turbine housing, machine tool beds, road roller, which we see wide applications in road construction. Engine blocks are used in large uh, thermal power plant. You will see turbine housing are just made. Turbine housing are actually the coverage which are done on the large size turbines, and these are also made by casting. Further we are moving. Now comes the what are the different size of the sand which we use for ramming. So the inner part of sand which we use for ramming, its size is around 10 to 15 micrometer, and there are basically three different kind of grain size which you will see after solidification. So what happens, at the surface of the casting there will be fine grains and their direction will be randomly oriented. Then comes columnar grains, or they have a certain direction, and at the center you will see equiaxed grains. So in equiaxed grains are the best part, then comes columnar, and third one is fine grains. There is a formula from which questions can be asked, that is Tp is equal to Tm plus delta T. So what it actually signifies is Tp is the pouring temperature, the temperature at which the molten metal is poured into the mold cavity, and Tm is the melting temperature of that metal, and delta T is degree of superheat. So what happens if suppose you have to cast some metal from steel? So melting point of steel is around about 1500 degrees Celsius. So if you have to pour the steel into the mold cavity, so you will heat it not to 1500 degrees Celsius, but you will heat it somewhere between 1700 or 1800 degrees Celsius, and then you will pour it, because during pouring and at the time it will just reach the mold cavity, some extra heat will be just dissipated into the atmosphere and it will be absorbed by the molding sand. So if the temperature just goes below 1500 degrees Celsius, you can understand that it will start solidifying in between, and chances are that we will get a defected casting. That's why we are just increasing the temperature somewhere between 200, 300 up to 500 degrees Celsius. Here you can see just an interview question which is mostly asked in PSUs is, you will observe in your house that the gas cylinders which we use in our houses is just made by adding or welding two different metals. So drawing is just used to make these metal or metallic sheets, and in between you will see that there is a welding done all around at the middle portion of the gas cylinder. So in interview they will ask that what are which is the different types of welding process which is used to just weld this gas cylinder, and this submerged arc welding is used. You have to remember this. Then we will move further. There comes one more point, and in this point it is just saying that the pressure inside the mold cavity must be less than the pressure which is outside the atmosphere, because if the permeability, although the permeability of the molding sand is good, but if the molding sand inside the mold cavity the pressure is more than, and in outside the atmosphere the temperature is or the pressure is more, then it will not start casting.